All right, so we've basically got a number properties problem solving question here. They give us this equation, which I've already written out, and they say which of the following must be true. So that word must is super important. It's not which of the following could be true, it's which of the following has to be true. So in order for these two sides to be equal, if you look at the first equation, which I've multiplied and distributed the x to get two terms here, the xy plus xz. If we compare that to the left-hand side of the equation, I could subtract xy from both sides, and I'd end up with an equation that looked like z equals xz. Now, you have to be careful because this is where algebra can get you in a little bit of trouble, but basically, I know that if I divide z on both sides, I'll get x equals z over z, which means x equals 1. And on the other hand, so I know x could be equal to 1, but on the other hand, if you look at this equation, if we make z equals 0, we wipe out both sides because anything times 0 is 0. So whenever we have a situation, and this is a great note card to make, if you have a equals a times b, either a is equal to 0 or b is equal to 1. And they could both be true at the same time, but in the situation I have, I don't need them to be true simultaneously because I could have a is 0 and b is 7, and they would still be equal. Or I could have a is 15 and b is 1, which is my b rule, and they're still equal as well. So I don't need them to both be true. They could both be true, or either of them could be true on their own. And that's why we're looking at the or statements, answer choices D and E instead of the and statements, because it's either true in the equation that we were originally talking about, that either z equals 0, setting both sides equal to 0, or x equals 1, which would make it equal z times z. So it's either going to be 0 equals 0 or z equals z, and that is why our answer is E.